Let's discuss this question next. What does this question say? A manufacturer produces 3 products X, Y and Z which he sells in 2 markets. Okay, there are 2 markets, market 1 and market 2. Annual sales are indicated below. Annual sales of the products X, Y and Z are indicated below in this table. Then we have part A, which says if unit sale prices of X, Y and Z are rupees 2.5, 1.5 and 1 respectively, find the total revenue in each market. Find the total revenue in each market. There should be and rupee 1 respectively. Find the total revenue in each market. Okay, with the help of matrix algebra. How do we find that, right? So this matrix is clear. We'll get one matrix from here. Okay, what we'll get is one matrix will be obtained from here. This is 10,000. The first row will represent the first market. The second row will represent the second market. The first column would represent the first type of product. The second column will represent the second type of product. This is a matrix for sales. Okay, and when we want the revenue, we need another matrix for the price, right? Sales times price, number of items sold into the price would be actually the total revenue. So this is a matrix for sales. We can find another matrix for prices, and on the basis of by multiplying them we can get the total revenue, right? So this is the sales matrix, right? This is for sales. Let us call this A. Let sales be represented by A equals this, where rows represent the markets, market 1 and market 2. We could have had another market, market 3, market 4, market 5, and the columns represent the product types X, Y and Z, right? This is product X, product Y, product Z, right? This is a sales matrix. What about the price matrix? Let price be denoted by, be represented by matrix B. What does it say? For multiplication, right? These prices, this row will get multiplied with the column having prices, right? So what you have is prices of X, Y and Z are 2.50, 1.50 and 1.00. This is the price matrix and it has to be in the form of a column. Right. And now we can get the revenue. Therefore, revenue can be obtained by multiplying these two matrices together. Revenue would be equal to this: 10,000, 2,000, 18,000, then you have 6,000, 20,000, 8,000 gets multiplied with 2.5, 1.5 and 1.00. This is what I get, right? On multiplying these two, what you get is in the first row you'll get the total revenue of first market, and the second row you'll get the total revenue of second market, right? This is a 2 by 3 matrix. 3 by 1 matrix will give us a 2 by 1 matrix, right? So net for market 1, revenue in each market could be found with the help of matrix algebra using this approach. What you have over here is this. Let's multiply them together. This first row gets multiplied with the first column. Let me just check the numbers once a bit. 2,000, 18,000, 20,000, 8,000 and 6,000, right? So we are multiplying 10,000 with 2.5. So this is 25,000, right? 25,000 plus 2,000 times 1.5 is 3,000 plus 18,000 times 1 is 18,000 only. Then the second row will be obtained by multiplying the second row with the first column. This is 6,000 into 2.5. 6 to 12, 30, 15. This is 15,000 plus 20,000 into 1.5, which will be 30,000, plus 8,000 times 1 would be 8,000, right? This is what you get. And can you add these numbers? Yeah. What you get is a total revenue, which will be equal to 18 and 28. 46,000 is what I'm getting over here. This is 46,000. And the second row, what you get is 45 and 8 is 53,000. This is what you get, 53,000. That's the total revenue from market 1 and market 2 respectively. From market 1 we get a total revenue of 46,000. From market 2 we get a total revenue of 53,000, as you can see over here. Next, The second part of this is also there. What does the second part say? If the unit costs of the above three commodities are rupees 2, rupees 1 and 50 paisa respectively, find the gross profit. Okay. So one is the selling. This is the selling price. This is the final revenue that we get. And we also have something called cost. Okay. So same number of units, this sales matrix will be same, right? For same number of units, we have to find the cost, the total cost, the first market and second market. On the basis of that, we can find the gross profit in the two markets, right? Let's see what we have over here. We'll have to modify a few things. This final result is important, mind you. This revenue, when we talk about revenue, revenue can be represented by this matrix. This is 46,000 and 53,000. Let's keep that safe. 53,000. Yeah, let's write it over here. And now we want to talk about the cost for part B. So sales matrix would be same and the cost matrix would be different. Sales matrix would be same and let cost is represented by C equals this matrix, matrix C, which will be 2, 1 and 50 paisa, 2.00, 1.00 and 0.50. This is what you get. Right? So this is the cost matrix, and once we have this, then we can find the total cost. First, let's find the total cost. Total cost would be product of this and this, matrices A and C. What do you have over here is 10,000, 2,000, 18,000. Let's write the numbers. 10,000. Then we have 2,000 and 18,000. The second row has, in the second market, we have 6,000, 20,000 and 8,000. The cost that is involved in preparing these products is 2, 1.00, 0.50 respectively for the three types of products X, Y and Z, right? So this product X is prepared in 2 rupees, Y is prepared as 1 rupees and Z is prepared in 50 paisa, as you can see. And the total cost can be found easily by multiplying these two matrices together. What you have is 10,000 times 2 is 20,000. 2,000 times 1 is 2,000 plus 18,000 times 0.05 is 9,000. The second row will give us the cost for the second market. What is that? 6,000 times 2 is 12,000 plus 20,000 times 2 is 1 is 20,000 plus 8,000 times 0.5 is 4,000. That's the total cost when we talk about the second market. What happens next? Next, total cost can be obtained by adding these. 31,000 is the total cost in the first market, and 1224, what is that? 36,000 is the cost in the second market. Okay, we have revenue, we have cost, and now we can easily find the profit. Profit is simply how much do you sell for minus how much did you spend it, like how much money did you spend for preparing it. So making versus the revenue is basically the profit. This minus this will give us the profit. So let's find the profit after this. Let's get rid of this. The profit can be found over here. Profit would be actually revenue minus cost. What is that? This is 46,000, 53,000 minus what you have over is 31,000, 36,000. And the final value would be 15,000 for the first market, and what do you have get over here is 17,000. This 14 plus 3, 17,000 for the second market. This is the profit from the two markets. From the first market, you get a profit of 15,000. From the second market, you get a profit of 17,000. That's why final answer for this second part as well. These are parts A and B, and you can observe the practical application of matrix algebra with the help of this question, right? We could have more number of markets, we could have more number of products and the individual values of the sales depending upon the cost and revenue, we can find the net profits and then make decisions accordingly, right? So this is the important thing about this question. I hope you have understood the complete solution clearly, right? You can also rewind if you want and go through this question again, right? That is all for this question.